Okay, I just want to do 8, 9, and 12 with you, and then I'm going to leave you to do a couple of examples on your own. Okay, so here's a pitfall that a lot of kids fall into, and that is seeing a numerator and a denominator, a rational expression, and they go, oh, I'm going to apply L'Hopital. But you don't. Not in this case. So let's do our limit of the numerator, x approaches 1, of 5 to the x. Well, 5 to the first power is 5. So right off the get-go, I know I can't use L'Hopital because I can only use L'Hopital if I have a 0 over 0 or infinity over infinity. The limit of the bottom, x to the third, well, 1 cubed is 1. So this problem becomes 5 divided by 1. That is too bright. Let's see. Is that any better? 5 divided by 1, which is 5. So don't get sucked into the trap thinking that every rational function you're going to be able to use a L'Hopital on. Okay? That's not the case. Okay, let's do number 9. I'm going to do the limit of the numerator, e to the x minus 1, as x approaches 0. Well, e to the 0 is 1, minus 0 is 1, minus 1 is 0. So the numerator goes to 0. Let's do the bottom. Cosine of x minus 1. Well, the cosine of 0 is 1. 1 minus 1 is 0. So that means that I can apply L'Hopital's rule here. So I get the limit as x approaches 0. The derivative of the numerator is e to the x minus 1. And the derivative of the bottom, well, you remember the derivative of cosine is negative sine of x minus 0. So I'm going to look at this and go, well, e to the 0 is 1 minus 1. I still get 0 on the top. And the sine of 0 is 0 on the bottom. So technically what I have to do is I have to now show this again. The limit of the numerator, e to the x minus 1, goes to 0. The limit of the denominator also goes to 0. And I have to apply L'Hopital's rule again. So I'm going to come down here, and I get equals the limit as x approaches 0. Now the derivative of e to the x minus 1 is e to the x. The derivative of negative sine of x is negative cosine of x. And now I can plug my 0 in. E to the 0 is 1. Cosine of 0 is 1. Make it negative. And I end up with negative 1. All right, one more problem. We're going to skip down to 12. This is kind of an interesting problem. Okay. I'm going to go with this one. So we have an integral sign. So I'm going to do the limit of the numerator, the limit as t approaches negative 2, of the integral from negative 2 to t of x cubed dx. Let's think about that. If we are plugging negative 2 in for t, the integral from negative 2 to negative 2, it's going to be 0. Let's do the limit of the bottom. T approaches negative 2 of 6 plus 3t. Well, if I put negative 2 in there, I get 3 times negative 2 is negative 6. 6 minus 6 is 0. Okay, so this is a L'Hopital's problem. So let's go to our derivative. The limit as t approaches negative 2. All right, this is a sneaky way to get the fundamental theorem of calculus in there. Verge came up with this problem, by the way. I really like this problem. Okay, so the derivative of an integral just gets us right back to where we started, except that it's not x cubed. We plug t in. So we would get t cubed. And then the derivative of 6 plus 3t is just 3. Then we can go ahead and do our direct substitution. We get negative 2 cubed in the top, 3 in the bottom. So negative 2 cubed is negative 8 over 3, and we get negative 8 thirds. Okay, so let's see what we got here. Let me get all my papers in order here. Whoops. So we went through the notes. We did 1 and 2 together. We did 3, 4, 5, 6, and 7 together. And we did 8, 9, and 12 together. So that leaves 10, 11, 13, 14, 15, 16, and 17. So I'd like you to try those problems. And tomorrow we will maybe do a circuit. All right. I'll talk to you guys later. Bye.